Hello students, my name is Dr. Darshana Mhatre from Ideal College of Pharmacy and Research. Today we are going to cover ANOVA. ANOVA, it is a statistical test from the Biostatistics semester 8 syllabus. ANOVA, it is also called as analysis of variance. It is a parametric test which is widely used in the scientific study for the statistical analysis. This test is widely applicable for both the type of data, that is pair data as well as independent data. From this test you can compare large set of data as well as you can compare more than one variable in a single test. So, to start with the ANOVA basically it is divided into two types, one way ANOVA and two way ANOVA. So, one way ANOVA is used when only one variance is to be compared and two way ANOVA is used when more than one variable is to compare. Today we are going to cover one way ANOVA where we will study the contingency table of one way ANOVA and the formulas which are respected to this one way ANOVA solving. As the ANOVA, it is a hypothesis testing, and for any kind of hypothesis testing we have to start with the first step. Our first step starts with the selection of test. So, when the question is directly asked regarding solve the ANOVA table, you know the test that is to be selected is the ANOVA. So, you will directly write the test is a ANOVA. Then you have to state the null hypothesis and the alternate hypothesis. So, what is null hypothesis? Null hypothesis says that there is a no significant difference in the variance, while what is alternate hypothesis? Alternate hypothesis tells that there is a significant difference between two things. So, these are being mentioned as H0 for the null hypothesis and H1 or H alpha for the alternate hypothesis. So, once you are done with stating your null hypothesis and the alternate hypothesis, you have to select the number of tails. When your question is one ended, that time you have to select one tail, and if your question is two ended, you have to select two tails. For example, if your question is whether there is a significant difference or not, that time you have to select two tail, and when your question states that A is greater than B, that means it is a one ended question, you have to select the number of tail as a 1. So, as our question we will assume it is a 2 tail, we will write the number of tails 2. Then comes is the level of significance, it is denoted by alpha. Alpha says that whether there is a 95% acceptance, 90% acceptance or 99% of the acceptance for your test. So, if your question does not states the level of significance, we have to assume the level of significance as 95%, and for that we write the alpha as a 0.05. After you state the level of significance, then you have to go for the degree of freedom. For ANOVA, you have to refer the F table, and for referring to the F table, you will require the values F1 and F2. So, how to calculate the F1 and F2? The formula to calculate F1 is equal to C minus 1, where C is number of columns, and to calculate F2, the formula is C into R minus C, where C is the number of columns and R is the number of rows. So, when you calculate F1 and F2, you can refer F table for F critical value. Once you are done with stating all these parameters, then you have to start with solving the contingency table. Here is the contingency table for one way ANOVA. We have the column stating the sources of variance, degree of freedom, sum of square, mean sum of square and F value, and all these we have to calculate for between, within and total groups that we have taken for the calculation. The first column for the degree of freedom, to calculate the between degree of freedom, the formula is C minus 1, that is number of columns minus 1. For within degree of freedom, the formula is row into column minus column, and for total degree of freedom, the formula is row into column minus 1. With this we will solve the degree of freedom column. Then comes is the sum of square. We have to calculate the between sum of square, within sum of square and total sum of square. So, the formulas for calculating this are being given over here. You can see here the formula to calculate total sum of square it is equal to summation of capital X square minus capital X the whole square divided by capital N. Here this capital N is the total number of sample which is calculated by C into rho, while these capital X are nothing but the total of the samples observations of the columns. Then comes for the formula of between sum of square. So, for between sum of square, the formula is summation of x1 the whole square divided by n1 plus summation of x2 the whole square divided by n2 plus to the value xn the whole square upon nn minus summation of capital X the whole square divided by capital N. So, this is the formula with which you can calculate between sum of square, and the formula to calculate within sum of square is total sum of square minus between sum of square. So, with all these three formulas you can calculate the sum of square for this column. So, once you have calculated the sum of square, you have to go for calculating the mean sum of square. So, the formula to calculate between mean sum of square is sum of square for between divided by column minus 1, and mean sum of square for within is calculated by the formula sum of square for within divided by row into column minus column. So, with this formula you will calculate the between mean sum of square and within mean sum of square. Once you get the mean sum of square for between and within, you will go for calculating the f value. The formula to calculate the f value is equal to mean sum of square for between divided by mean sum of square for within. This will give you the f calculated value. Once you have got the f calculated value, you have to compare this with the f critical. F critical you will get from the F contingency table. So, from that you have to refer whether there is a difference in the F critical and F calculated value. So, if there is a difference between F critical and F calculated, that means your alternate hypothesis is accepted. If there is no difference between F calculated and F critical, that means the null hypothesis is accepted. So, what do you mean by null hypothesis? Null hypothesis means there is no significant difference, while alternate hypothesis says that there is a significant difference. So, with these formulas we will able to calculate the ANOVA table, we will able to calculate the f values, and we will able to refer whether to accept or reject the null hypothesis or the alternate hypothesis. So, I hope with this you are clear with the contingency table for the ANOVA, and you will find it useful for solving the problems based on the ANOVA. Thank you.